Anyway, it's great to be here at FOSS4GE and to see some familiar faces and still see some faces here at my talk. Yeah. Yes. So my name is Stefan Achtznet. I have studied mathematics several years ago. Yes. But what always has fascinated me more than the algorithm part was always the data side. So how you get all the data inputs to your algorithm and what you finally do with the data. And that was a challenge which kept me busy for the last 20 years. And I'm currently working at EOX. Perhaps some of you know EOX. It's a geospatial consulting company from Vienna. And we also had a lot of FOSS4G talks over the last years. Yeah. And it's, as I said, it's geospatial. So there's a lot of data and a lot of struggles in this regard. But what we have learned over the years is, at least for a few of these struggles, on how to manage them. And so besides uh, consulting people, we also try to focus on bring some best practices tools based on some fundamental research to the people, and therefore we also created a separate company, Versioneer, and some of the ideas we are exploring there and working on to productionize. This is something I will present now, but this is not a product talk. This is just to lay the ground for some foundations. Good. So what is the challenge? What is the challenge I'm talking about? So Earth observation data is used more than ever. So it's used in agricultural insurance, it's used in climate monitoring, it's used for emergency disaster response. But often it's not enough to just have data. Yeah? So what we need really to make sure that the right people get the data in a way so that they can trust on the data and reuse the data. And we see reproducible data collaboration as the defining challenge of the EO data supply chain. So EO data supply chain, that's perhaps a complicated word. So what do I mean with data supply chain? So think of EO data supply like a product line in a factory, for example. So we are starting with raw data, we are processing it, the data gets cleaned, it gets combined, fused, it gets labeled, it gets finally packaged, and last but not least, it gets delivered. Yeah, and for sure, we want to have the final data set, the final data to be reliable and complete. And whether it's then used by a human analyst or a machine learning algorithm, machine learning model, or just an application running on an edge device. So that data must not be just accessible. Data should also be reproducible, context rich, and it should also be verifiable. So a lot of Earth data, so definitely not just limited to Earth observation data, this is still shared as single files through formats like netcdfs, cloud optimized geodifs, and always with some kind of file-based model. Yeah, so we are exchanging files. And these files are then put on some FTP server in your university on some shared folder. In the cloud, you usually have some object storage. But while this model of file-based sharing is quite intuitive and also compatible with all with the way we think and also which our tools are using, yeah, it does not inherently support methods like version tracking or checking if everything is complete. Yeah, because usually you are not just passing one file, but many files. So there are some problems with data integrity and so on. Yeah, and as data gets bigger, this approach definitely falls short. So as the data itself, the files itself, it lacks some additional structure. Yes, so perhaps, I guess many of you have heard of the term stack or the spatial temporal assets catalog, and this definitely provides such kinds of structure. And it also became some kind of de facto standard to describe data and search for EO data. Internally, it just separates the metadata part from the actual payloads, the files. So it gives some rich browsable catalogs instead of the ad hoc folders we used in the past. So this definitely helps with discovery. But it doesn't make sure that we really get the full data set, because each data as a stack item, it points to one or multiple assets, yeah. But then it's still your responsibility, your tool chain which then needs to get the data, and you're still not sure if the data is really complete without, if you're not doing some additional steps, if you don't add additional measures. And that's not enough. So why this is even more relevant today, yeah? While many EO tools and users still think in terms of files, the underlying structure of the data has changed. So there are a lot of cloud-native formats. There are formats like SAR, there are partitioned Parquet files, there are chunked netCDFs, and there the data is naturally organized a lot of across many files. Yeah? And users still want to explore and analyze the data in flexible ways, so they're happy that they can stream them just individual chunks down to the client. But others still need to have full verifiable data sets. So I mentioned the automotive example before was a good example that you really want to be sure that all the trees are probably in your model and there was not a tree missed. Yeah? And if you also follow, perhaps some of you know the initiatives from ESA and NASA regarding the reprocessing or the re-engineering of all the Sentinel data, the Copernicus data, and there the new target format is probably SAR. So I think they already agreed to have it in the SAR format. But if you follow this community streams, yeah, and all the people who are working there, yeah, you see exactly the same questions popping up everywhere. Yeah? So if you have such kind of SAS structure then for the Copernicus data, yeah? Also now used for imagery, yeah? How to structure and describe the folder, these folders you have? Do you point the stack item to the root part of the folder? Do you then point further down within your structure? Is it better to have the data compressed or zipped or tarred? Do you want to have the data flat, or are nested layouts better for cloud-native workflows? So there are definitely different needs. On the one hand, we can see the tool chain for the data access, where you have the streaming part, and there I think we all converge to some kind of common standard. Yeah? There are great tools like SAR and Parquet as data formats. There are client-side tooling like DuckDB. Perhaps some of you heard that for analytics purposes. This is also the new fancy candidate to get data down. Yeah. Then there are all the processing engines like Spark, and all of them, they are now adding geospatial support. Apache Iceberg is also a good example. There are the really smart guys. They are working to bring the geospatial concepts also there. Yeah. But on the packaging side, it's not so converged. Yeah? So on the one hand, we want to have the data reproducible in a standardized way, but there is no common agreement at the moment on how to do it. There are some rather niche standards like research objects. Perhaps some of you have heard of that. There is Bagit, and there are some standards evolving, yeah, but there is no big convergence in the overall tool chain. And this is exactly something where we see some opportunity for the geospatial community, for the Earth data community, to adopt some standardized tooling. And this standardized tooling could be OCI. So OCI stands for the Open Container Initiative. And this originally comes from the world of software, of Docker, from the container world. But this OCI thingy, this is also great for data too, because it lets us package data with all the needed files and metadata in one verifiable bundle. And these bundles, these data packages, they can then be stored in standard OCI registries, and they already exist. There is Docker Hub, there is AWS Elastic Container Registry, there are offerings like Hava, KIO, and so on. Yeah? So we have already some kind of ecosystem, and an ecosystem where also the client tooling exists and where a lot of people are already familiar with it. Because many of you probably have already used Docker pull and push, and conceptually it's nothing different if you pull and push a container image with software or data. And this definitely lowers then the barrier to bring such kind of standard in research and in industry. Yeah? If there's already an existing ecosystem and you don't have to convince all the people to follow a new standard. And what's also nice is that it enables cross-domain adoption, because there is some kind of specification which is already shared, which is established. So there is the image specification, which defines the layout of the content you want to exchange. There's the distribution specification, which describes all the flows with pulling and pushing artifacts. There are runtime specifications, but they are not so relevant in our context. So for this, let's have a short look on the structure of such an OCI artifact. So in Generally, it's quite simple. So there is just a config part, which is the metadata. Then you have the layers, which are actually the data payloads. They are usually stored as compressed binary blobs, and they are addressed then via cryptographic hashes, as this is just a content addressable storage layer. And on top of that, we have a manifest which links all the things together. So why we think OCI is relevant for EO data? Yeah, there we have to deal with multi-gigabyte data sets and need to not just access this kind of data, but also to handle, share, and distribute them. So as said before, the files are tracked by content, so which means they can be addressed via the content hashes. And these hashes itself, they are just some kind of blobs, chunks, and they can be considered as immutable. Yeah? So this means they are not changed or edited. You just point there and they are stable there. But you have then some asynchronous process which is doing some garbage collection if you really want to remove all data. Then the nice thing is also that the data is packaged as layers. So if you have appending data sets and so on, then the files are not necessarily duplicated. So there is some inherent deduplication in place. And what's also really nice of the OCI standard is it's possible to put some kind of attestations on top of your data packages. Yeah? So you can put provenance information, you can put data quality checks and all this stuff. And there are formal specifications for exactly that. So you're not reinventing the new kind of mechanisms to add this information. What all the OCI implementations already have is some kind of pluggable storage at the bottom. So you can point them to object storage, you can point them to your network file storage and so on. And many of them are then capable to serve the data in a quite efficient way. And last but not least, there is this OCI 1.1 standard, and this really raises now the bar for non-software artifacts, because now also artifacts in their general form are standardized. So originally, this comes from the AI machine learning world. So perhaps some of you have heard about the Docker model runner, which is coming now in place. So many people are starting now to put their machine learning models also in this kind of OCI registries, because there they can reuse all the existing mechanisms I presented before. So just a short disclaimer on, we are still at the packaging level. So just shortly explain, we are not just packaging the data, we also need to deliver the data, and there are a few mechanisms, and people usually share the data. So on the one hand, you just have the direct team-based access. So you are inviting more or less a group of people into your round and give everyone access to this shared folder to access the data. Then another possibility is to use pre-signed URLs. So this is quite popular in the cloud world. So these are temporary URLs where you can then access data items, but they have the inherent problem. They are just pointing to one file, to one object. So if you have to share a folder, you have to generate pre-signed URLs for all of them, or other way, you first zip them and then just make a link to this zip thing. But that doesn't solve or doesn't help usually. Yeah? Then there is the peer-to-peer staging. Yeah? This sounds quite esoteric, but I think this is the common model on how people in industry work with all the commercial data providers. Because if you order, for example, very high resolution products from Planet, you give them just an object storage bucket, and Planet itself, they push the data then down to your bucket. Yeah, so this is what I mean with peer-to-peer peering. And last but not least, it's also possible that there is this scoped credential delegation. Sounds fancy, but it means that you have an additional security token service which supports you to get proper credentials for a short time and access exactly the pieces you need. But this needs additional infrastructure like the security token service to be properly used. Yeah? So what we think is, and why OCI is so applicable, is because the whole OCI concept is just relates to this peer-to-peer staging. Because what you are building up, if you do a Docker pull, an OCI pull, yeah, you are more or less instructing the whole engine to push the data from this remote OCI registry down to your local OCI runtime. And this can be local, or this can be on your remote server, wherever you are triggering the pull. So how did we do now this OCI evaluation in practice? So we just used one larger data set, a benchmark data set. We used a panoptic agricultural satellite time series reference benchmark data set. It's called FOSS4GE. And to test, so in general, it contains various data items. It contains Sentinel-1, Sentinel-2 data. It contains some VHR data. It contains labels. So this is just used for some purpose over France in the agricultural domain. Yeah. And to test the approach with OCI, we used this data set and packaged it up in completely different ways. And so on the one hand, first of all, we tried to make as many, we used a tile-based approach where all of these 2,400 tiles, yeah, they got compressed into small layers. So we have a lot of small layer files then within a package. And then we used a completely orthogonal approach, yeah, where we just took the 4 regions which are part there and put them in a separate layer. So we have then only a few layers, but they are quite large in size. And then we try to push them to these various registries and just investigated how good or how bad that worked. Yeah. And now, yeah. So we pushed it to Docker Hub, to AWS ECR, to KIO and all these things. And you can see, so we tried pull, push, add attestations, checked if the data is complete. Yeah, if we interrupt the download, what will happen then? And these things we verified. And as you can see, most of the things are green here, but Docker Hub is not so green. Yeah, I wouldn't say that's a failure of Docker. It's just we used a free subscription, and Docker implies some limits on throttling and some additional things. So if you want to evaluate something, then probably for managed services, you have to be careful on what you really want to test and understand. Good. So to come to a conclusion, so many people and applications, they want to have full ready-to-use data sets, and platforms like Hugging Face or EUTDL in the machine learning community, they already showed that this is really necessary and has a high uptake. Yeah? On the other hand, users are not collaborating on files, but they want to collaborate on data sets, bundles, and OCI artifacts. They provide really a way to package data with some additional context. So the OCI artifacts, they don't replace the files, they just wrap them and make them accessible in a consistent way. So what are the takeaways? So Stack definitely was a game changer, as it has been incredibly successful in enabling discovery of your data sets and providing all an additional structure which is needed. Yeah, but Stack itself just solves the discovery problem. Yeah. And if we now use this stack concept and combine it with OCI registries, we have a very powerful capability to also solve the packaging and delivery chain. Yeah. What still remains a challenge, whatever you package up there, you have to agree on some kind of metadata, and in the OCI world, this is called media types. Yeah? So perhaps a media type then for cloud-optimized geotiffs, for SaaS and so on. But there, the community needs to agree on some standards we can push there. And I think the internal standards, they are already given by Stack. So that's the last slide now. Yeah. So I think this is when we are just at the beginning of a journey, and we just introduced an established concept which could be established for the EO domain, and this has now to be uptaken by us to make it real if we see value, and so we have really to go for it one package at a time. What I just described here, also we published a blog post which you can follow here, and so this is work done by the companies EOX and Versioneer, and a lot of links are then leading to further research we are doing in this regard, and also to the tools and the concepts we are promoting. Thank you very much.